Hello viewers and students, once again you are welcome to this channel where we shall continue the series of teachings on Alkanols. I started a series of teaching on Alkanols in my previous video where we consider the meaning and classification of Alkanols. Kindly subscribe to this channel so that you can have access to these videos, and don't forget to turn your notification bell on so that anytime there is a release of new updates, especially this series of teaching on Alkanols, you can always have access to them as soon as possible. Today we shall look at another way we can classify alkanols, and that is based on the number of alkyl groups attached to the hydroxy-carbon in their molecules. Classification based on the number of alkyl groups. The number of alkyl groups represented by capital R that are attached or bonded to the hydroxy-carbon, hydroxy-carbon in their molecules. Hydroxy-carbon atom in their molecules. That's another condition for classifying alkanols. In the previous video, we looked at the first way of classifying alkanols based on the number of hydroxy groups present in their molecules. Today, we are looking at another way we can classify alkanols into groups based on the number of alkyl groups attached to the hydroxy-carbon in their molecules. When we are talking about hydroxy-carbon in a carbon chain of a molecule of alkanol, we are referring to the carbon atom in that chain that the hydroxy group is attached to. The carbon atom in the carbon chain that the hydroxy group is bonded to. That's what we mean by hydroxy-carbon. And the presence of hydroxy group makes this compound to be called alkanols. So based on the number of alkyl groups, how many alkyl groups are attached to this hydroxy-carbon atom in their molecule, we have the following. We have those that are called primary alkanols. Primary alkanols. We have secondary alkanols. Secondary alkanols. Secondary alkanols. And lastly, we have tertiary alkanols. Tertiary alkanols. These are the three classes of alkanols based on the number of alkyl groups that are attached to the hydroxy-carbon in their molecules. So we have primary, secondary, and tertiary alkanols. For the purpose of this class, we are going to concentrate on primary alkanols. We want to see what primary alkanols are and how we can identify a primary alkanol and the examples of primary alkanols. So let's consider primary alkanols for the purpose of this video. We are looking at primary alkanols. Primary alkanols. Primary alkanols. What are primary alkanols? Don't forget that we are looking at the classification of alkanols into various types based on the number of alkyl groups attached to the hydroxy-carbon atom in their molecules. So we are looking at primary alkanols. And what are primary alkanols? These are alkanols that contain only one alkyl group, only one alkyl group attached to the hydroxy-carbon in their molecules. One alkyl group attached to the hydroxy-carbon, that is the carbon atom that is bearing the hydroxy group, hydroxy-carbon in their molecules. These are primary alkanols. They contain only one alkyl group attached to the hydroxy-carbon atom in their molecules. They are also alkanols that we can describe to contain the hydroxy group. They contain the hydroxy group. You can say they contain the hydroxy group. The hydroxy group, that's OH. The hydroxy group attached to the terminal carbon. The hydroxy group attached covalently to the terminal carbon. What do we mean by the terminal carbon? Terminal carbon is a carbon atom that is at the end of a carbon chain. Any carbon atom at the end, either starting or ending a chain of carbon atoms, is known as a carbon atom, a terminal carbon. So they contain hydroxy group attached to the carbon atom in their molecules. For example, let's look at this structure to illustrate this statement. We have a chain of carbon atoms as follows. A chain of carbon atoms as follows. The first and the last carbon atom in this chain, this is the first, second, third, and fourth. The first and the last carbon atom in the chain, those are the carbon atoms at the ends of this carbon chain. They are the ones we refer to as the terminal carbon atoms. They are the terminal carbon atoms. So when you have hydroxy group, on this carbon atom or on this carbon atom, then you have what we call a primary alkanol. So let me just leave only one of the hydroxy group. So this structure is describing a primary alkanol that has the hydroxy group attached to the terminal carbon, that is the carbon atom at the end of the chain or at the start of the chain. Like I said, the carbon atoms numbered 1 and 4, carbon 1 and carbon 4. They are the ones we can refer to as the terminal carbon atoms in the molecule. So if you have hydroxy group on either of the two, you have what we call a primary alkanol. Let me try to complete this structure so that to give us a complete molecular structure of a primary alkanol. So this is a molecular structure of a primary alkanol. The carbon atom is on the terminal carbon, the carbon atom at the end of the chain. And like I said, the primary alkanols, they contain only one alkyl group attached to the hydroxy carbon. The carbon 4 is the hydroxy carbon and is also a terminal carbon. We can also say that primary alkanols, they are represented by a general molecular structure, or formula rather, a general molecular formula, which is RCH2OH. That's the formula we can use to represent primary alkanols. They can be represented by that general molecular formula. This represents primary alkanols. They are represented by that formula. So when you see in a molecular structure of an alkanol showing this CH2OH and it has either an alkyl group or hydrogen atom attached to the hydroxy-carbon in that CH2OH, that means the molecule represents a primary alkanol. It represents a primary alkanol. Let me try to illustrate that. Let me try to illustrate that too for you to see what I mean by this general formula. So for instance, you have RH, RCH, then OH here, and this. So we can see that there is an alkyl group and also we have CH2OH group. So that means the CH2OH group is what we can use to identify a primary alkanol. So I can say also that primary alkanol, they can easily be identified. They can easily be identified by the presence of the CH, the presence of the CH2OH in their molecules. So these are the things we can say about primary alkanols. They contain this group in their molecules. So immediately you are able to sight your eyes on this particular group in their molecular structure. In their molecular structure, it means you are representing a primary alkanol. So they contain the presence of this CH2OH group in their molecule or in their molecular structures. When you write the structure of a primary alkanol, what we are going to see is this CH2OH group. Let's look at examples of primary alkanols. Examples of primary alkanol. Let's look at the molecular structure of primary alkanol. Let's look at examples. Examples of primary alkanol. I'm going to start with the simplest member of the primary alkanols, and that is methanol. Let's look at methanol. Methanol is CH3OH, or we can write the molecular structure as follows. We have this. We have the OH attached to the carbon atom, and there are two hydrogen atoms. There are three hydrogen atoms. Now, if you look at this, we have the CH2. We have the CH2OH as follows. That's the characteristics of the primary alkanol. But we have a hydrogen atom here. This hydrogen atom is not really an alkyl group, but is the only one. That methanol is the only one in which the alkyl group R is simply replaced by H, by hydrogen atom. So it's the only one that has is R to the hydrogen atom and not really an alkyl group. So I can simply represent that as follows. I can write this to represent methanol, just to show the CH2OH. The CH2OH is what I can also refer to as the specific functional group of primary alkanols. That is what we use to identify primary alkanols. It represents the main functional groups of the primary alkanol that makes them to exhibit their chemical properties, the CH2OH group. So this is an example. Let's take another example. Let's consider another example. Another example is ethanol. Ethanol is a primary alkanol, and that is represented by CH3CH2OH or C2H5OH. Let's consider the molecular structure. We have 2 carbon atoms. There are 2 carbon atoms in the molecule. And we have hydroxy group on one of the carbon atoms. And that carbon atom that bears the hydroxy group is going to be called the hydroxy-carbon. Then we have an alkyl group. In ethanol, there is a specific alkyl group. The alkyl group is methyl group. This the alkyl group. That's the alkyl group. This alkyl group is a methyl group. Is a methyl group. This is the alkyl group, and that is a methyl group. That's the simplest alkyl group. Don't forget that it is only methanol that the R is replaced with a hydrogen atom, but it's still a primary alkanol. Why? Because it contains the CH2OH, which is an identity of a primary alkanol. It's an identity of a primary alkanol. So this is ethanol. Ethanol. This is ethanol. I can simply write it also this way. I can write it this way. CH3 and CH2OH. The CH3 is the alkyl group that you can find attached to the hydroxy-carbon atom or the CH2OH. So that's another example. Let's take another example. I'm going to take another example, which is propan 1-or. Propanol, but precisely propan 1-or, because we have 2 types of propanol. So we have propan 1-or as a primary alkanol, propan 1-or, which is represented as CH3, CH2, and CH2OH. Always try to identify the group, the CH2OH, to indicate that it's a primary alkanol. So look at the structure. The molecular structure is as follows. Don't forget that the carbon atom in the chain that bears the hydroxy group is also known as terminal carbon. Any carbon atom called terminal carbon is a carbon atom at the end of the carbon chain, either the first or the last in that chain. Like in this case, we have the first, the second, and the third. So if I have the hydroxy group on this, if I have the hydroxy group on the first carbon atom, on this carbon atom, the hydroxy group is represented as follows. On this carbon is attached to this carbon atom. That means the carbon atom numbered as 1 is the hydroxy-carbon, and it's also a terminal carbon. Carbon 1 and carbon 3, carbon 1 and carbon 3, they are terminal carbon atoms, and one of them is bearing the hydroxy group, and that is the hydroxy-carbon. The carbon atom that the hydroxy group is attached to is the hydroxy-carbon, and this represents the alkyl group. The alkyl group that represents the alkyl group. The alkyl group is represented as follows. The alkyl group is represented as follows. So that's the alkyl group. That's the alkyl group. The alkyl group, and that alkyl group in propan 1-or, this alkyl group is ethyl. That is CH2CH3, and that is an ethyl. So if they ask you to name the alkyl group that is attached to the hydroxy-carbon in propan 1-or, it is ethyl. So this is a primary alkanol. This is a primary alkanol. So we shall continue this in the next video. Don't forget to subscribe to my channel and turn on the notification button so that you can have the complete series of teachings on this topic. See you in the next video. Thank you.